method that's called u substitution. Okay, and what you're going to do is you're going to let u be the entire lesser power. Okay, so in this case, it's the entire exponent e to the x. Okay, if you let u be that lesser power, and then the second one is twice that. So if you say u squared, and you take e to the x squared, is going to be e to the 2x, and notice that that's this second power. Okay, and so by using u substitution, what you can then do is rewrite your equation. Instead of writing e to the 2x, we're going to replace that with its equivalent u squared. And instead of writing e to the x, we're going to replace that with its equivalent u. And this gets us a new equation, u squared minus 13u is equal to negative 22. Okay, this is now an equation in quadratic type, or in quadratic form, and we can solve it like any other quadratic. So in this case, if I move all my terms to one side, because I have multiple variables, I add 22 to both sides. And I can look to see if I factor this, what happens. My first two terms of my binomials are u. My second two terms have to have a product of positive 22 and a total sum of negative 13. So that would be negative 11 and negative 2. And then I could solve each of these for u. So here I get u is equal to 11. Here I get u is equal to 2. When I'm using u substitution, once I actually solve for u, what I'm going to do is back substitute. So here's my back substitution. I'm going to put e to the x back in for u. And I'm going to solve the resulting equations. So this now becomes an equation where my base is e, but my power's my variable's in the power. So I can either rewrite both sides using the same base, which I'm not able to do, or take the ln or common log of both sides. Because my base is e, I'm going to take the natural log. I can now use the properties of the power in a log, move it out front. So this becomes x ln of e has a value of 1. So x is equal to ln 11. Here, move my x out front. Ln e has a value of 1 equals ln 2. So I just need to test to make sure those numbers can be calculated, and they're not negatives. If you tried to take the ln of a negative number, then it would not be possible. So these are my two solutions here, ln 11 and ln 2. And you would actually enter those as your solutions, separate by a comma. If you see that your power of one variable power is double that of the other, you have quadratic type. So I can use u substitution. If I let u be my lesser power, e to the x, then u squared is going to be e to the 2x, and that allows me to rewrite my expression as u squared plus 10u equals negative 21. So when you go through the same process that we did before, add 21 to both sides, and then solve it by factoring, we get two binomials u, the two factors of 21 whose sum is positive 10 is plus 7 and plus 3, giving us u equals negative 7 and u equals negative 3. Okay, when you back substitute to test and solve for x, you get e to the x is equal to negative 7, e to the x is equal to negative 3. And if you tried to take the ln of both sides, what happens right here? Can you take the log of a negative number? No. Same here. If you take the log of both sides, log of a negative number. So this one does not exist. So there is no solution for this problem. Same idea, use u substitution, e to the x. Therefore, u squared is equal to e to the 2x. And that allows you to rewrite this as a u squared minus 5u equals 84. Subtract 84 from both sides to move all your terms to one side, and then look to factor. The two factors of negative 84, whose sum is the middle term, negative 5, are negative 12 and positive 7. And so when you set each of these, you get u is equal to 12 or u is equal to negative 7. Back substitute. I get e to the x is equal to 12, e to the x is equal to negative 7. And so here, when I look to take the log of both sides, move the x out front, ln of e has a value 1, so ln, or one value for x is equal to the ln of 12. When I take the log of both sides here, again I have this negative, which cannot happen. So this one is an extraneous solution, but this one works, and so my only answer would be ln 12. Now remember, when you're entering these, you would need to put parentheses around them, okay, when you enter them online.